first of all, thanks for joining this session. I know you're probably a bit hungry. It's lunchtime, so thanks for being there. I'm very happy to be here today with you at Future Tech after this long period of in-person event. So I would like to start this presentation by asking you a question. Can someone define what is a cloud-native application? Can someone define what is a cloud-native application? No, not nobody? Okay. Because a lot of people are actually currently discussing cloud-native application, but there is no, at least nobody talked really about what is a cloud-native application. So I will try to first define in this presentation what is a cloud-native application, or at least on which definition I rely to for this talk. And then I will demonstrate how we can build a cloud-native application with .NET and AWS. I'm François Bouteruche. I'm a senior developer advocate at AWS. I focus on .NET developers. I'm a .NET developer myself for more than 15 years. As you may have spotted, I'm a French person. Thanks to my, it depends on the country. Some say my terrible French accent. Others say, oh, you're so cute, French accent. So it depends. So today, so I will start trying to discuss this topic with you. So let's first review what is cloud native. And I would say the only definition is the one of the Cloud Native Computing Foundation. I would say it's kind of official definition of cloud native. So let's read it together. Cloud native technologies empower organizations to build and run scalable applications in modern, dynamic environments such as public, private, and hybrid clouds. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. So let's stop on this first paragraph. Here we are discussing the technology that are cloud native, and one important thing here to spot is that containers and container orchestrator are cloud native technologies, but they are not the only one by this definition. And you can see around in our industry and in third-party conference, there is a kind of we are reducing the scope of cloud native to containers and container orchestrators, but there are other technologies that are cloud native. So let's read the second paragraph. These techniques enable loosely coupled systems that are resilient, manageable, and observable. Combined with robust automation, they allow engineers to make high-impact changes frequently and predictably with minimal toil. So this second paragraph defines what is a cloud-native application. The expected characteristic of a cloud-native application is to be loosely coupled to other applications, to other systems, to be resilient, manageable, and observable. That's the expected characteristic of the application you will build leveraging cloud-native technologies. So a lot of things. So now we've seen this, we'll try to build a cloud-native application. But before going to building this application, let's discuss the business context. Because we don't build application just for building application, we build application for a business case, for a use case. So here we will rely on a fictional online marketplace, I Love My Local Farmer, that with some solution architects and developer advocate at AWS we've built to tell the story of a company that are migrating from their own on-premise data center to AWS. Why we've built this fictional company? Because we have a lot of public reference from customers, but we can't share deep technical details from what we do with them. It's it is their secret sauce, and they don't want to share their secret sauce. So we've built this fictional company to go deep into the detail, to share some implementation details, some tips. So you can learn more about this story on ilovemylocalfarmer.io. And so today, so basically it's online marketplace allowing customers to buy fresh fruit and vegetables to local farmers. They go on the marketplace, they order, and then they go to the farm, pick their order. That's the story. And there is a B2B team inside their organization because they need to onboard more and more farms on the marketplace. And the team has a process. When they onboard a new farm, they need to get proof of address from the farm. So right now, the farmers send by mail, so not email, by mail, their documents, and human operators process the document, validate the document, and store them in a proof of address database. And the stakeholder of the company the business stakeholder want to modernize this process and to automate this process to be able to reallocate this workforce to more valuable tasks. And the development team handling all the B2B application is the .NET development team, and they have to build this application. So let's give it a quick look at the application. Okay, so right now they've built, okay, no, you don't see it. No, you see it. Okay, so they've built a Blazor WebAssembly application. So very simple. It's a proof of concept right now. And in this application, a farmer can sign in. Not this one. Okay. So the farmer can sign in, choose his file or her file. So this is a French document, real one, and upload the document. So then the document is uploaded, and in the back end it will be processed. Okay. So that's basically the application. So let's see. Okay, because this application, as you might see, is already deployed. So let's see the architecture of this application and how we can build it. Okay, so here the user of the application navigate to the page and interact with the Blazor WebAssembly single page application. So I won't go deep into Blazor WebAssembly today. It's not the focus of the session, but it's a Blazor WebAssembly application. So as it sees a static web application, it is served through a content delivery network. Here, Amazon CloudFront and CloudFront get the content from an Amazon S3 bucket. So Amazon S3 is a fully managed storage service that allows you to store your content without managing any storage server. And so you get the single page application content from there. And then when I click on the sign in link, I've been redirected to a backend for front-end API. Hosted on AWS App Runner, a fully managed service that allows you to run Docker container image. And it's basically a .NET Web API, okay? And this API has redirected me to our user store, Amazon Cognito, to check the user credential. Once the user is logged in, the Blazor WebAssembly application requests a pre-signed URL to Amazon S3, another bucket, to get a pre-signed URL. Because Amazon S3 can be accessible on the internet, but you don't want to make it public. Of course, you want your Amazon S3 bucket to be private, but you can get a pre-signed URL with the temporary credential of your user to allow your user to upload a document on this storage. So my Blazor WebAssembly application requests a pre-signed URL to my backend application, to my backend API. My backend API check user credential, and if the authorizations of the user is okay, it requests to a pre-signed URL to Amazon S3, and then the user is able, through the application, to directly upload his document to the Amazon S3 bucket. Okay, that's what we've just seen. Okay, but now the file is in the storage. That's fine, but how can we process this storage? We can configure Amazon S3 to send a message to a queue. Here, Amazon SQS, for example, it's a fully managed queue service. It sends a message to the queue to notify that the file, a new file has been uploaded into the bucket, okay? And then, this message, when it reaches the queue, it will trigger the execution of a Lambda function. So AWS Lambda is a function as a service. It allows you to execute your code, your C# and .NET code, without deploying any server. So it will trigger a background task running on AWS Lambda, and this task first will use one of our AI services, Amazon TextRack, to analyze the document, and then store the result of the analysis into a NoSQL database, here Amazon DynamoDB. So an application that seems very simple can, from an architecture perspective, can become very complex quickly, at least from an architecture perspective. So now let's see how we can build this application. Let's switch to Visual Studio. Okay, so let's close this to get space. So here is my Visual Studio solution. As you can see, I have several projects. Here is my web project. So it's my Blazor WebAssembly. It's a typical Blazor WebAssembly, except for the authentication. Not because I'm using AWS, just because I don't want to use the built-in OpenID Connect provider, because Blazor WebAssembly, the default authentication mechanism for a Blazor WebAssembly application is built on OpenID Connect. Here, I want to delegate my authentication to my backend for frontend API. So I've set up a cookie authorization workflow between my backend for frontend API and my Blazor WebAssembly application. And to do this, here I've just provided a custom authentication state provider. That's how you can do this. And here in my, here, I've implemented my own authentication state provider, and the only thing you have to do is to implement your own get authentication state async method, and you just have to return a claims identity. And Blazor WebAssembly don't care about how you build and how you get this claims identity object. That's your business. You've decided to take care of the authentication state. That's your business. The Blazor WebAssembly framework will just call this method, retrieve your authentication state, and say, okay, you're authenticated or not based on this. And that's fine. It's a client-side application, so you don't want to put too much authentication stuff on the client side, because you can have an attack. So that's it. And behind this, so I'm using my here in my get current user method. I'm using my user service, and my user service just call here just do a HTTP request to my backend for frontend API. And here the important things to know is to instruct Blazor WebAssembly to include your authentication cookie in the request. By default, if you don't instruct Blazor WebAssembly to include the authentication cookie in the request, it won't include it. So it's very important to instruct Blazor WebAssembly to include your authentication cookie. And then I just send a request to my backend for front-end API and retrieve the current user. And I do the same for the logging. So nothing specific to AWS, just to prove this. In my package, no AWS package here. It's standard Blazor WebAssembly code. Here, is the code for my Blazor, my backend for frontend API. And here in the program, so in the program file, I'm setting up my authentication. So the first scheme is my cookie scheme for handling authentication between my client app and my backend for frontend. And the second scheme is an OpenID Connect one to manage the interaction between my backend for frontend API and Amazon Cognito, our identity provider. And here I can safely use a client ID and a client secret because I'm on the server side, so I can use a client secret. So that's safe. So that's for the identity things. But here, nothing specific to AWS. I'm just using the middleware provided by ASP.NET Core. Okay. Where there is specific AWS stuff is only on my pre-signed controller. So as you can see here, I'm importing two packages from the AWS SDK for .NET, Cognito Identity, it's a NuGet package, and F3, it's also a NuGet package. Because here, so this is my get method to retrieve a pre-signed URL. And here, this method is authorized, so the authorization will be handled by the ASP.NET Core middleware. And so here, I can get from my HTTP context my ID token from my Cognito authentication scheme. And thanks to this, I can request to Cognito temporary credentials for this user to interact with my Amazon S3 bucket. So the pre-signed URL will work only for this user. So I will know that this user has uploaded this file. It's not a generic user for the application. It's really the logged in user that will be recognized as the one who has uploaded the file. So three lines of code to do this, and then I generate my pre-signed URL. To generate my pre-signed URL, I'm just using my Amazon S3 client object provided by the AWS SDK. I'm crafting my request. So what I'm telling here, I instruct to use my bucket. The key, so the key is basically the file name, which HTTP verb to authorize. So this pre-signed URL will work only for put request. You can get request, duration, and content type. If I try to upload, for example, a PDF file, it will fail. Okay? And that's it. That's the only code specific to AWS inside my code. Okay? That's fine. And now, so at this point, I have the code to upload my file on my S3 bucket. And now we will build the code to process the file. So first thing, I will create a new project. I will create an AWS Lambda project. So You can get this additional template if you install the AWS Toolkit for Visual Studio. It's an extension that you can find on the Visual Studio Marketplace. So let's give it a name. Background task. Let's create it. So here, it offers me to select different blueprints. My blueprints, I will use a simple SQS function. So this blueprint will bootstrap a AWS Lambda function project ready to be triggered by a SQS message. Okay, so SQS message. So simple queue service. So each time a message will reach my SQS queue, it will trigger AWS Lambda and give the message to my AWS Lambda function. So let's create this. So basically, for those who know Azure Function, it's basically the same thing. So here is my background task project. Let's open the function file, and here, this is my function handler. So when I will publish this code, I will instruct Lambda to automatically call this method each time the Lambda function is triggered. And here, it receives a SQS event object, and this object has a list, a collection of records. So the record is basically the message in the queue, because you can trigger the function for one trigger event for one message, or you can batch your message. And here, let's add some code here. This is the method where I will instruct AWS Lambda to process the message. So I've prepared some snippet code to go quicker. So the first thing I'm doing is I parse the body of the message. In a JSON document, I retrieve two pieces of information inside this message: the bucket name and the key for the object, so the file name. And then, based on this, I will call two methods: analyze document and store analysis results. So let's implement the analyze document method. Okay, and here I need to add a NuGet package here for interacting with TextTrack. So for each AWS service you want to use, you have the appropriate NuGet package to interact with it from .NET. Okay, so that's good. So let's reduce this. So my analyze document method, what I'm doing, I'm creating an Amazon TextTrack client object. So there is a pattern here. Each time you want to use AWS services, you basically have to create, you will find a client object for this service in the NuGet package. And then you craft a request object. So here, an analyze document request object. And here, I'm just instructing Amazon TextTrack that the file it has to analyze is stored in my S3 bucket. Okay, so I pass to TextTrack the bucket name and the key. So the file name, and I instruct TextTrack to run a forms analysis. And I just called the analyze document async method on the client object. Okay. Here, I won't go too deep into the detail, but here there is an algorithm to parse the result of TextRact. The algorithm is provided in the Amazon TextRact documentation, because thanks to the form analysis, it retrieves the key pair value. For example, in the document, if you have a field called first name and then François, my first name, it will retrieve the key pair value. And so this algorithm is just to parse the result and create the mapping. So now I want to store the results. So I need to implement the store analysis result method. Okay. And here again, need to add a NuGet package for DynamoDB. Okay. Okay. So same things here. You see the pattern. I'm creating a client object for DynamoDB. I'm creating a table here. So to be honest, here I've already created the table inside my NoSQL database. So I've coded the name here. And I'm creating a document object. And in this document object, I will add all the results of my analysis. So all the key pair values that have been retrieved from my document. And then I just call the put item async method on my client object. And that's it. Nothing more to do. So that's it. I've completed my background task. So let's deploy it to AWS Lambda. So right-click, publish to AWS Lambda. So let's give it a name to my AWS Lambda function. Next. So here you can see I could run my AWS Lambda function on ARM chip, because we do support ARM, and as .NET Core also support ARM, we could do this. And here I have to select a role. So I've already created this role with the proper permissions. Because I didn't discuss this before, but okay, how my AWS Lambda function can be authorized to interact with TextRact and with DynamoDB. Because I associate to my AWS Lambda function a role that have the proper permission. So the AWS SDK automatically search for the permission of the AWS Lambda function for the credential of the AWS Lambda function, and thanks to this, is able to interact with other services. If I don't give the proper permission to my AWS Lambda function, everything would fail, because it would say, no, you don't have the permission to interact with this service. So I don't have to manage any credential inside my code. The credential is associated to my function directly. And now I can click on the upload button. So I need to wait for it to publish. So let's wait a few seconds. So right now, you can see it is packaging, zipping, and uploading my code in the Lambda function, and that's it. My AWS Lambda function is ready to run, and thanks to the AWS Explorer and the integrated experience inside Visual Studio, I can see my function here directly inside my IDE, but I can go into the AWS management console too, and this is the same. This is my AWS Lambda function. Okay, and right now I didn't configure any trigger. So let's configure trigger. So my trigger will be SQS queue. So let's create a queue. Okay. So now my queue is created. It is already created. I don't have to do more than this. And let's create now an event source. Okay, so need to refresh this. Sometimes small glitch into the refresh. No, okay. What's going on? Okay. I just check what's going on. It should have been, yes, it is created. So I have a refresh issue there. That's it. Okay. Now it's there, so let's add it. And that's fine. And I've created, I've configured my event source, and you see, with a batch size of 10. So it can wait up to 10 messages before triggering my AWS Lambda function. And now, okay, I'm missing a link between my S3 bucket and my SQS function. So here I can go here. My application is using this S3 bucket, so you can see there are already 2 files in it. Let's delete this file. Okay. And I will configure the properties of my S3 bucket to notify my, each time an object is created, I want to send a notification to my SQS queue. So here, yes, my SQS queue. And that's it. So now everything should be good. So just to show you that my proof of AWS table is already created, it is there. Let's remove the first record, so nothing in my table. So let's reuse my application. Let's click on upload, and let's check in the bucket if there is something. So my file is there. My queue is probably already empty. No, it is not. I don't love what I'm seeing. It should be. So here, you see, there is one invisible message in my queue. It's probably because my function has failed at some point. So let's review the last log. So here it is. Here. The curse of small resolution. Okay, so I can get my log here. And let's see what's going on. So the given key was not present in the dictionary. Ready? Okay. So here you can see in the log. So it has logged my message into automatically into my into the CloudWatch services. It's our logging services. So I was discussing that our cloud native application should be observable. So I didn't do anything, and the logs are there. And here I can see that in the message, so the bucket name is OK, but the message is not OK. It's not the right format. Let's clear the log list. Yeah. No, I won't do this. So I guess something was not properly set up. Let me check. So the queue is set up. Let's remove this. I want to try it once more. Oh, yes, I know. I need to sign out and to sign in again so that my user has all the proper permissions set up. So upload. I can refresh. So my file is there. My queue is empty this time. Let's check the last log file. Okay. Let's check my table. No. Okay, so I don't want to, I missed something. Let's just check one more time. Okay, I know what's going on. Okay. I made a mistake. I shouldn't have used this name. I know what's going on. So here, I got a conflict with previously deployed function. Let's try to fix this very quickly because I'm good with the time. Let's change the name. That's okay. Sorry about this. I should have been careful. So I republish my my AWS Lambda function to avoid this conflict with another deployment I've done previously. So that's okay. So for this run, let's delete this. Here, let's reconfigure the source. Okay. And for my file storage, let's do the same. Let's change the notification. Let's remove this. Yes. And let's add it to. Okay. So let's sign out. Let's sign in. It's my last try because if it doesn't work, I don't think I would be able to debug this in the next 5 minutes. So let's give it a last try. So the file is there. Yes, because there are 2 files. Still have an issue there. Okay, so there is an issue with the message format. I made a mistake somewhere. I'm really sorry about this. That's the joy of live coding. Okay, so let's wrap up. So if I didn't make a mistake somewhere in the live coding, it should have worked. So we should have seen the result store in my DynamoDB. Actually, you see that I'm able to get my log, to have the detail, and I should be able to debug this in a few minutes. So let's wrap up. Okay. So what we've seen. So basically, it's standard C# and .NET for Blazor, WebAssembly, and Web API. I'm not using any specific code for AWS, except when I explicitly want to interact with one AWS services. You can leverage AWS services through the AWS SDK for .NET. And even if you don't host your application on AWS, for example, if you want to use our AI services, but you don't want to host your application on AWS, you can do it. There is no issue with this. It's up to you. You can interact with AWS services directly from your favorite IDE. As you see, I've stayed in Visual Studio. I didn't go into the AWS console, thanks to the AWS Explorer and the AWS Toolkit for Visual Studio, so you can easily interact with AWS services. And every services I've used, you don't need to manage servers to use these services. It's fully managed service that you just deploy, and we will manage them for you. You just have to care about your code, your application, and the business value you want to create for your end user. What we haven't seen in this presentation, we need to fine-tune permissions to apply least privilege policy. So I've discussed this a little bit for my AWS Lambda function, but you have to do this everywhere to ensure that each of your piece of code is running under least privilege policy. By default, you will be forced to do this. By default, we restrict everything. So by default, your piece of code running on AWS will have no right to do anything. So you will force to grant permission to your application to interact with AWS services or to execute something. We need to add logging and tracing to our application. So by default on AWS Lambda function, you get logging for free because you can just run write console.writeLine, and it will send your message directly into CloudWatch. It's built into the service, so it will send your console message directly into our log services. But if you want to do this into, for example, the Web API, you have to configure logging to send your logs to CloudWatch. And to do this, we have a package that integrates nicely with the logging middleware of ASP.NET Core. And we need to automate deployment and update of our infrastructure, leveraging infrastructure as code with CloudFormation or CDK. So that's what we haven't seen today. So a few key takeaways. You can leverage the AWS Toolkit for Visual Studio if you want to try. The SDK for .NET and our extension libraries to integrate nicely with ASP.NET Core extension points. And you can also leverage AWS serverless and container services. So try it out. Don't be afraid. I'm a C# developer for more than 15 years. 2 years and a half ago, I wasn't thinking about building .NET application and run them on AWS. I've tried, I've loved it. Now I work with this on a daily basis. You can try it with our free workshop. So we have 3 nice free workshops that you can follow to give it a try. And the code of this session, so the whole code of what I've published, I've showcased today, with the infrastructure as code to deploy the infrastructure, will be published soon on GitHub. I'm in the process of releasing the code. It's nearly ready, and I will announce it on Twitter and LinkedIn. So thank you for your attention. If you have any question, feel free. And my Twitter handle and my LinkedIn account are there. So if you want to reach me after the event, you feel free to contact me. Thanks for your attention.